Hello, I'm Maria. Today we'll be facing the law. Not all laws, but some laws. Specifically, the laws of physics. You see, before the universal laws in physics came to be, there existed and thrived a collection of scientists who contributed to the body of physics we have come to learn today. And I mean our understanding of mass, momentum, and energy conservation. First thing, the quantities called mass, momentum, and energy can be conserved, meaning after an interaction or a reaction, no part of the quantity is lost. The first law we'll be discussing is the law of conservation of mass. This law was proposed by Antoine Lavoisier, a French nobleman and chemist. This law states that mass in an enclosed system is neither created nor destroyed by a chemical reaction. Therefore, the mass of the reactants must be equal to the mass of the products in a chemical reaction. Now, let's look at this list of people who contributed to our understanding of mass and its conservation. Here we have the ancient Greek philosophers who believed that nothing comes from nothing, implying that everything present has an origin. Nasir al-Din al-Tusi, a Persian polymath who wrote that a body of matter could only change its form, condition, and other properties. It cannot disappear completely. Changes could only turn it into a different form of matter. Mikhail Lomonosov, a Russian writer and polymath who disproved the phlogiston theory by burning metals, showing that the mass of metals remained the same even after burning. And if you're wondering, the phlogiston theory assumed that matter contained phlogiston, which is a fire-like substance that existed in combustible materials. The theory suggested that phlogiston contained within combustible bodies were released during combustion. Mikhail proves that to be untrue. And last but not the least, Antoine Lavoisier, the man who proposed the law of conservation of mass, stating that in a chemical reaction, the total mass of the product is always equal to the total mass of its reactants, proving that atoms are neither created nor destroyed, but rearranged to form new substances. Next is the law of conservation of energy. This law states that energy cannot be created nor destroyed. It can only be transformed from one form to another. Hence, the total energy of an isolated system can never change. Our set of scientists who contributed to the development of this law are Galileo Galilei. This Italian astronomer and physicist studied an interrupted pendulum, showing through his experiment that the energy in the pendulum was conserved, causing it to swing at the same height it was released from. Because if energy was not conserved, the pendulum would have stopped and would have been incapable of completing its swing. Basically, he demonstrated that kinetic energy can be converted to potential energy and vice versa. Christian Huygens, he is the Dutch mathematician who published his law of collisions. Okay, that sounds messy. Noting that the kinetic energies of colliding objects were the same before and after the collision. Gottfried Wilhelm Leibniz, a German polymath and philosopher, he derived a mathematical formulation of energy that is related to motion, kinetic energy, from Huygens' work on collision. This mathematical formulation is called vis viva, the Latin word for living force. Émilie du Châtelet, the French mathematician and philosopher, proposed that energy is different from momentum by performing experiments, where she dropped a ball into soft clay at different heights. From that experiment, she discovered that the ball's kinetic energy was proportional to the square of its velocity, as well as the fact that the deformation of the clay was proportional to its initial potential energy. Albert Einstein, the staple scientist with that wacky photo. Anyway, this man developed the theory that united the concepts of mass and energy. His energy-mass equivalence implies that neither mass nor energy are separately conserved, but could be interchanged. Therefore, the total mass energy of the universe is conserved. Law of conservation of momentum. Law of conservation of momentum. Momentum is conserved the same way mass and energy are conserved. This law, suggested by John Wallace, states that the total momentum of an object does not change. It remains at rest or in motion with constant velocity, if there are no external forces acting on it. And a roll call of our dear contributors to this law. Jean Buridan, the teacher and philosopher who first used the term impetus as a signification of the notion of momentum. According to his theory, an impetus set an object in motion and increases along with the object's speed. René Descartes, the French philosopher and mathematician who proposed that the total quantity of motion of the universe is conserved and equal to the product of our object's size and speed. This is similar to the modern concept of conservation and momentum. However, Descartes possessed no concept of mass that was different from the weight and size of the object. John Wallace, this English mathematician, suggested the law of conservation of momentum, stating that a body will remain at rest or in motion unless an external force that is greater than its resistance is applied, quite similar to the first law of motion of Sir Isaac Newton. And lastly, someone we just talked about, Sir Isaac Newton, the English physicist and mathematician who defined the quantity of motion as a product of velocity and mass. This quantity was later defined as momentum, implying that when no force acts on the object, the quantity of motion is conserved. The end.